let's continue. If I remember correctly, we already implement this, but in Lambda, this make me curious though. I mean, like, can we add this? I think it was called, what is it? Asset static, something like that. So I'm thinking maybe we can, what is it called, abort the compilation when the length did not or is not the same, something like that. Compile time and compare to 0. If it compare to 0, if it is compare equal to 0, compile time error occurs. Let me try. I'm not sure if we can evaluate the variable during, what is it called? During compile time. Maybe something like this. What? But in the right. Okay. I kinda forgot. File. Implicit. Okay. Looks like we need the assert header. It is not constant. Okay. But well, so we cannot evaluate the variable. But I think we can evaluate using side of directly, right? Something like this. All right. Okay. Let's see. Did not match. 14, okay. 14. Oh. Wait, let me check. Okay, interesting. Yeah, we haven't, what is it called? We haven't defined an env copy. That's why I got an error there. So if it is 0, right, or false, okay, let's try again. Alright, okay, this is interesting. Since C11, deprecated. Okay. Reference. Long name spelling. So I need to find this as macro. Maybe. So maybe something like this. Really? Size of, what is it called? Array, and then size of array 0, something like this. Starting assault. Array from names array. No, from names. Alright. incremental. And then let's check the reprocessing result. Is it code again? Static assert. Okay. And then don't think we need this anymore. But yeah, so I save that inside this variable. Maybe we can just use this. Unuse, okay. Let me check. Or not def, sorry. It should be let, right? And then arcs, let arcs 16 and 42 x y. Okay. Size of, okay. Utils static assert. Okay. I mean, we are evaluating this during compile time, so it should be fine, right? Array, where is it? Let's try that out. I print F. And sign. Or I can do this too. It's basically the same. Okay. But yeah, I'm still not sure how to check during compile time. Not really during the pre-processing stuff, I guess. Okay. Okay, copy. Right. Okay. We've given function, then an environment. In this environment, we will place the values that their formal arguments are set to. Okay. Oh. Wait a minute. Maybe let's call it lambda env like this, and then lambda env. env, right, and then lambda env. Okay. Oh. My stomach's okay. When we come to evaluate the body of the function, we can do it in this environment and know that those variables will have the correct value. And we come to evaluate the body of the function, we can do it in this environment and know that those variables will have the correct value. When we come to evaluate the body of the function, do it in this environment and know. Oh, so it's like a local environment to place the, what is it called? The parameter or the argument value of the function, of the lambda function, And then it also the place to store the result of the calculation of those functions. Maybe something like call stack, but instead of one environment, we have an environment for each function. It is interesting. Okay, but ideally we also want this. Function. But ideally we also want this function to be able to access variables which are in global environment. So we have local environment per function, and then also global environment, which is the one that we initialize at the beginning. This one. Like built-in function, for example. You can solve this problem by changing the definition of our environment to contain a reference to some parent. By changing the definition of our environment to contain a reference to some parent environment, then when we want to evaluate a function, we can set this parent environment to our global environment. Oh, we want to evaluate a function, okay. It has all of our built-in defined within, and also the global variable, something like that. When we add this to our lenv struct, conceptually, it will be a reference to a parent environment, not some sub environment or anything like that. Conceptually, okay, when we add this to our lenv struct, conceptually it will be a reference to a parent environment, not some sub-environment or anything like that. Because of this, we shouldn't delete it when our len environment gets deleted, or copy it when our environment gets copied. The way the parent environment works is simple. Okay, if someone calls lenv get on the environment, and the symbol cannot be found, it will look then in any parent environment to see if the name value exists there, and repeat the process till either the variable is found or there are no more parents. Okay. So we look at the local environment first, and then we look at the global environment. If the variable does not exist, to signify that an environment has no parent, we set the reference to null. The constructor function only requires basic changes to allow for this. Okay. Okay, let me change that in here, right? So what is it called? Start a pointer to, let's call it global. Other than par. I mean, other than parent and child, I think I want to use the term global and local. Something like that. So I call it global env. Yeah, let's call it global envs. Okay, and then we need to edit the init function. Count 0. Global env. Well, I think we can, what is it called? Initialize null with 0 in ANSI character set. Okay. I think we can check in GDP. What is it called? No. Oh, I kind of forgot how to set a variable in GDP. Add variable $sign. Convenience far, okay. Oh, let's type that. Wait. Oh, okay. The null one. Okay. But anyway, let's just use null instead of 0 to make it easier to understand. Hello, welcome Absolute. So how do I start? Just start, I guess. I mean, you can follow along the book if you want. Or yeah, if you mean start programming, then try out, what is it called? Creating a simple program, for example, hello world, right? To make you familiar with the syntax and stuff, or maybe the concept, like looping and something like that. But yeah, just start creating something, even something simple as this, using the printf and something like that. Make sure you are, what is it called? Make sure that you are really implementing something rather than just reading about it, I guess. Yes, just start. I'm not really sure how to give advice to that. I mean, for example, I want to learn C, so I just start learning C, mostly by following this book, but as you can see, pun intended, I also implement something that doesn't exist in the book. Right, this is the implementation in the book. I'm also adding some safety guard when the memory allocation fail, something like that. Okay, to get a value from an environment, we need to add in the search of the parent environment in the case that a symbol is not found. I need to get breakfast after this. To get a value from an environment, we need to add in the search of the parent environment in the case that a symbol is not found. Okay. Okay, we are using recursive again. If no symbol check in parent, no symbol check in parent, otherwise error. Okay. Okay, let's change that up. I think, well, maybe we can do something like this. Global env not equal no return env get. Let me recursive. We are using this function again instead this function. Okay, env global env and then the value, I guess. Right, this is k, this is k. Okay. Not that I look at it. the K1, the K parameter only use same, the symbol. Maybe we can simplify this to use only the symbol, if that is what we are using. Let me check. Oh, okay. You're using this in here. Interesting. Maybe I should commit to previous static, asset static, I guess. Let me check. Okay. But is it evaluate during runtime or compile time? I assume this is evaluated during runtime. It is quite different from asset static. No. What is it again? Not really. Oh, static assert. Is that it? Static assert, okay. Similar to assert, but it works at compile time. Okay. A compilation error with an optional message when the input is false or 0. Okay. Okay, let me commit that. This one, the one we use the array line, not this one. I don't think this one. Nope, not this one. Okay, not this one too. Oh, wait. This one and this one. const is refactor. Static. To validate env init. Rather than the equality, I guess the of railing for is it called names and function some pointers. Pointers during runtime. We can validate that during compile time. Validate that during compile time. And throw an error. And throw an error if the range not the same. Feels like this. The feedback during compile time is faster than waiting. Feels like for this validation the feedback during compile time is more convenient, I guess. Rather than where we need to run the program first to realize that to initialize the length for serialization, the elements, I guess. The total elements for and pointers during initialization is the same. The total element for function name and pointers not the same. Okay. let's see how it goes. Let me try that. Get stats. Take back information and then okay. Yes, it didn't throw an error. Okay. Pop again. Whereas in case someone new, it's just basically an alias for this comment. So if we run this comment or alias, we basically running this comment just to keep things, what is it called, sorter to type, something like that. If it is not node, then we're doing this. Okay. Because we have a new alpha type that has its own environment, we need a function for copying environment to use for when we copy a file struct. Right, finally we are implementing the lenv copy. Yeah, I'm kind of curious though. Why the author, what is it called, put the implementation or definition of this function later on, after we already used it in here. Okay. Yeah, I'm not really sure. Copy. Okay. We allocate that. Gone. Oh. Okay. Allocate a new. Yeah, we allocate new memory for all the symbols in the environment and also on the value. Okay. Copy this one. Okay. Let me check. Alpha copy. Or maybe, wait. Okay, let me check. Not really maluk. Maybe in the init. No. And built in. No. Oh, in the pod. Okay. I think that's what I've been thinking. Okay. Alpha env copy after. Okay. Env copy. Struct. What is it called? Env. Okay. Give you some tips where to start. I mean, it depends. You can start by reading this book, I guess. I mean, what do you want to learn about programming? If you want to learn what is it called? If you don't mind learning the hard way, then maybe you can learn C. I mean, C, what is it called? In C, we need to do a lot of stuff manually. So you really need to keep in mind what's going on, I guess, more often than using another programming language. But yeah, if you overwhelm learning C, maybe you can start using something like Python or JavaScript. I think that might be easier for beginner to start their programming journey. So yeah, it depends. What do you want to learn? Okay. This is sorted again. This is doing this. Using the same variables here. Okay, let's not change this. I don't have inspiration for another explanation. Okay, so start lenv. Let's call it copy, right? Then malloc copy, something like this. Oh, says off. How can I forget that? Yeah, I mean, if we didn't use says off, then I'm not sure what malloc will get. Yeah, it's gonna be a disaster, I think. Okay, we copying this one, right? Copy, what is it? You can forget. Global elf, okay. Right. We didn't use para for the field. We use global elf, so we need to use this and then the count. And field count. Okay. Let's use this. The overflow indicator. Unlock size. Void new unlock. This is so that we can the same variable. Okay. I need to copy this comment. Maybe. And sign in. We might need here some magnet overflow indicator. Okay. Instead of env. Oh, wait a minute, no, not like that. We need to do this, okay. But yeah, later on we need the I to, okay. We need to do this, alright. New unlock util. What do we want again? Okay. Seems then false. The unlock util I think it was okay. PTR. But we want to resize. We want to resize is no. Sorry. It should be using null. This one. Oh no, not that one. I think this one. Using null with relog is equivalent to malloc, at least from the main page, I guess. This one. If p is null, then the call is equivalent to malloc size. So the PTR is null, and then this is the total element, I guess. Copy count. I mean, we already copied this in here. And then size of for now. Oh, wait. I don't think we need void. Oh, yeah. Okay, looks like we need void so that we can change to this different allocation. Okay, RENV seems, I guess we are handling this first, and then if new unlock is null, I mean we are treating this like malloc, right? So where is it gone? Maybe something like this. But yeah, instead of malloc, let me check. Okay. Is there any like unlock util? I kind of forgot. Oh. Okay, I'm still using relog. Alright, let's use that. If you put new unlock. Wait a minute. Copy same, copy count, and count. Every count. Tournament size. Oh, okay. Yeah, because the symbol and the value should be the same, should have the same count or total, something like that. Let's cast this to char. Like that. Copy count. And then, well, can do this again for files. Look, okay. But the difference is that other than char pointer, total element and size. The size of file is a pointer. And file. Alright. Okay. For loop I equals 0, I less than, let's use the copy one instead, plus right. I send this to no, because we already done with that. Maybe I should copy the value first. Alright. Maybe doesn't really matter. Okay, string length, okay. Overflow indicator, right? Built in string length seems something like this. So one also unlock size. Okay. After done that, overflow indicator. In overflow. If not, let's copy that. Unlock size. Copy that. Right, this one. Okay, and then copy files. Copy. Something like this. And then after this, we return the copy. Unlock size. Oh, okay. Sorry, we need to use the memory trace or the pointer. Okay. At least it compile. Having environment also change our concept of defining a variable. There are two ways we could define a variable now. Either we could define it in the local innermost environment, or we could define it in the global, right? Maybe in say something like, again, the call stack, the local variable is the call in the call stack, and the global variable in the global outside of the function, something like that. Outermost environment, we will add function to the both. We will leave the env both method the same. It can be used for definition in the local environment. We will add function to the both. We will add a new function. A new function. Oh. It can be used for definition in the local environment. We will add function to the both. We could define it in the local. Okay. We will leave okay method the same. Can be used for definition of the local environment. Okay. We add new function called env for definition in the global environment. Oh, okay. This works by simply following the parent chain up before using env boot to define locally. Interesting. Thread till A has no parent. Let's put it in and we copy. Okay. Void, right. Okay. env. Let's call this let. Built-in boot. Built-in boot. Struct env. Value. Wait a minute. No, I don't think. Right. I need to change that to pointer to char. I think I might also want to change this. I mean, if we take a look, the value that we are using is only symbol. Yeah, and back then I didn't really realize that. Well, let's see. NVSim, and then pointer char as the same, and then looks like I forgot to also change this. Wait. Let me commit that real quick. No. Okay, something like this. So you twist that ends. LNV put para consistent with the one using value instead of this is a minor change anyway. This here. Okay. In the innermost of the right. This is for the global, right? Okay. And we go P and NV. Alright. Struct NV same value. Okay. While NV, what is it called? Global NV not equal null. Right, because the global environment did not have this parent field or something like that. So we check until this one either null or not. And then if it is not null, we replace that. What else? Something like this, maybe. Interesting. Okay. And then env, same value. This is the declare variable in global environment. Hello, welcome, kick load. Currently I am trying to learn C by following this book with Your Own Lisp, and we are currently on chapter 12, I guess. So yeah, let me check this first. This distinction may seem useless, but later on we will use it to write partial result of calculation to local variable inside a function. We should add another bit in for local assignment. We'll call this put in C, but give it the equal symbol in Lisp. We can add our built-in function and they use the common code just like we do with our mathematical operation operator. Okay. Built-in def. Let me check. Built-in light, okay. What is the difference though? We have this. Oh, I think the difference is in this one. This one, I think. Cannot define non-symbol. Cannot define non-symbol. Maybe I should change this. Okay. Do something like long chord expression. But yeah, I'm not sure. Is it gonna be too long? I don't think so, I guess. Maybe something like this. At 69, okay. Until this, okay. Let me change that real quick, or commit that. Yes. Not this one. Maybe I should use tile instead. Let's call it jar. Okay. Message none. To make it consistent to use non-format for the yeah, that make me should I use no, I think this is okay. I mean okay, where am I again? Feel light. Put input. For local assignment. Okay. Put in there. It is input in. Put in let. And put in function to add local assignment. And then maybe let's call this built-in let, and then this one global var, and then this one local var. Maybe something like that. Possible naming scheme. Put in global var. Okay. And use local assignment, global assignment, built in global var. Maybe something like this. Put in local var, put in global var. Use let the reusable the between local var and maybe something like this. Okay, I think we will continue this on the next session. That's it for now. Thank you for watching and see you next time. Bye bye.